chapter, we're going to be looking at the first law of thermodynamics. A lot of our study of thermodynamics will be focused on the three main laws of thermodynamics, and this chapter covers the first law. In the next chapter, we'll look at the second law dealing with entropy. First law of thermodynamics mostly deals with energy, heat, and work. And then we'll also look at the third law, which is also related to entropy. Before we get into any of these laws of thermodynamics, though, one thing we need to define in thermodynamics is the idea of systems and surroundings, and what we mean by these terms, to be specific. So, in general, the system we could call what we're studying. So maybe this is a reaction mixture, maybe this is a piston, but whatever we're interested in. And then surroundings are everything else, literally everything else. The entire rest of the universe. Generally, we just mean the things close by, or the only things that are going to matter. But so if we say are looking at a chemical reaction inside of a flask, we would call this would be our system. It would be the flask and the reaction mixture. And then the surroundings would be everything outside of that. So this would include like the air, the rest of the room, etc. So that's a basic idea of what we mean when we're talking about systems and surroundings. Now, there are different types of systems that we will be considering in thermodynamics. Basically, there are three types. So we have open systems, closed systems, and then isolated systems. And these are generally depend on whether we think about matter and energy and whether they can be exchanged between system and surroundings. Open systems, we can have matter that can exchange between the system and surroundings, as well as energy. So the flask that we just considered would be an example of an open system because things can evaporate and go into the surroundings, so that's matter transfer. We can heat the flask up, we can cool it down. That would be a transfer of energy. And so we can exchange both. A closed system has no transfer of matter, but energy can be transferred. No matter transfer. Yes, energy transfer. All right, so this would be something like if we had our flask, but we put a lid on it, right? And now things can't escape the flask anymore. But we could still heat it up, cool it down, that still would be possible. And then an isolated system is one where neither matter nor energy can leave the system. No matter or energy exchange. Now, I'd like you to pause the video here and think about what are examples of each of these kinds of systems. I've given a couple. Okay, so hopefully you took the chance to pause and think about this. The open system, fairly straightforward, reaction flask, whatever, something that's opened in the colloquial sense of the word, right? There's no container that it's inside of. A closed system may be like a bag of chips, right? Could be a closed system, right? You can't, the air won't escape until you open it, right? That's sealed. Or just anything where you can put a lid on it, but you can still heat it up and cool it down. And then the isolated system is maybe the trickiest one. Probably the closest thing, I'll say approximately, something like a coffee cup. Something that's trying to keep the heat in. You got to be specific here with a lid, or else you want to be isolated. A thermos is approximately a closed system, or an isolated system. Right, and so we can consider these different types of systems, and these will affect sort of what the properties of these are going to be like. So we're going to look at these different kinds of systems throughout our study of thermodynamics.